Here's a picture of an ogive. It accumulates frequency as the x variable values increase. To better comprehend, let's start with our histogram on family sizes. Notice that there was only one family with one person and 5 families with 2 people. This implies that the cumulative total of families who have 2 or less family members is 6, 5 plus 1. Since there are 7 families with 3 people, we add 7 more families to the total of 6, and now we have a combined cumulative total of 13 families at or below size 3. Notice in the ogive that when x is at 3, the cumulative frequency is at 13. The ordered pair of 3, 13 on the graph implies that a total of 13 families have 3 or less family members. Look back to the histogram and notice that 8 families have 4 people. This means that the ogive at x equals 4 needs to add 8 more families to the total. Therefore, the cumulative frequency by the time families of size 4 or less are combined is 21. This ogive can also be called a cumulative frequency graph or cumulative frequency distribution because that is precisely what it displays. You may be asked to find the quartiles and calculate an interquartile range or even construct a box plot from information found on an ogive. Let's look at an ogive imposed upon a histogram that shows the number of college credits earned by 400 employees at a certain company. Notice the y-axis. It says cumulative relative frequency. This means it is keeping track of the proportion of employees who have made it to a particular number of credits earned. Also recognize why the ogive increased so much, going from 120 to 150 credits. This is typically the credits required for a bachelor's degree. Over 40% of the employees are in this range. Thus, the cumulative total went from low 40% to upper 80% as a result of adding this proportion or relative frequency from this interval of 120 to 150 credits. To construct a box plot from this ogive, one could just grab the paper, go to 0.75 on the y-axis where the 75th percentile or third quartile would be, and find the third quartile by moving horizontally from there until we hit the graph. Then drop straight down to the x-axis to estimate the number of credits at the third quartile. We can repeat a similar action to find the lower quartile, moving across from the 0.25 mark on the y-axis. We estimate the lower quartile to be about 68 or close to it. We can easily find the median at the 50th percentile, looks to be around 127, and finally we can create a properly scaled box plot using the x-axis as the variable values of interest to get a visual of the distribution of credits earned for all employees. Remember the additional names for ogives, cumulative frequency distributions, and cumulative relative frequency graphs or distributions.